Today we're going to look at Introduction to Venn diagrams, so let's just jump straight into it. So what is a Venn diagram? A Venn diagram is a visual representation that shows the relationship amongst two sets, okay? So if we let our universal set be the numbers 1 to 15, so we're basically saying when we say universal set, all of the things we are considering, we're just going to do 1 to 15, otherwise we would be here forever. But we can get more specific than that. So here's our Venn diagram. And we're going to say set A is the multiples of 2 and set B is the multiples of 3. So the universal set is the numbers 1 to 15, all of the numbers, and then we're getting more specific with set A, multiples of 2, and set B, multiples of 3. So if we list everything in cell A, the multiples of 2, we would have 2, 4, 6, 8, 10, etc., all the way to 14. We're not going to include 16 because that's beyond the universal set. We're only going from 1 to 15, remember? And then in set B, the multiples of 3 are 3, 6, 9, 12, and 15. So remember what we've said up here, that this is a visual representation to show the relationship between these two sets. And the intersection is the part in the middle, okay, where these sets overlap. Sometimes we do more than 2 sets, you could have 3 or 4, but in Lantau and when you get introduced to Venn diagrams, you'll stick with 2. So any numbers that fit both sets or both criteria at the same time, I'm going to go here in this intersection. So if we think of what numbers they are, it's 6 and 12. 6 is a multiple of 2 and a multiple of 3, so it belongs in the intersection. It does both criteria. Same for 12. It's a multiple of 2 and a multiple of 3, so we're going to place it here in the intersection. We're now going to consider what goes here, which are the numbers which fit set A's criteria, multiples of 2, but not set B's criteria, multiples of 3. So the numbers that are multiples of 2 from 1 to 15, but not multiples of 3, are 2, 4, 8, 10, and 14, and that's why they're here. They're not in this part because they don't fit both criteria at the same time. They only fit set A's criteria, multiple of 2. And by the same logic, 3, 9, and 15 will go here, because they fit set B's criteria. They're multiples of 3, but they are not multiples of 2, so we're not going to put them in the intersection. We should also consider that some numbers aren't going to fit either criteria. They're not a multiple of 2, and they're not a multiple of 3. We place them on the outside of the Venn diagram to show that these numbers, or whatever it is we're looking at, they just don't fit into either of these sets criteria. Okay, and that's fine, but we need to remember they're there. So 1, 5, 7, 11, and 13 are numbers between 1 and 15, which aren't a multiple of 2, and they're not a multiple of 3 either. So they go on the outside. But we normally get questions which is just a summary of the data. We don't get all of these numbers from like 1 to 15 or 1 to 30 or whatever it may be and asked to place them inside the correct place of the Venn diagram. We get a summarization of results, and we have to use that in a Venn diagram to help us find more information. So let's do a question like that. Let's have a look. So in this scenario, we've got people being interviewed at a school talent survey about their musical abilities. 32 people were interviewed in total, 32 students, where 14 responded that they sing, 12 responded that they play a musical instrument, but 5 people said that they can do both. So we want to make a Venn diagrams to find how many students only sing, okay? Not sing and play an instrument, they're just a singer and nothing else, which is still very impressive. So when we set up our Venn diagram, we're going to let set A be the number of students who can sing and set B be the number of students who play a musical instrument. It doesn't really matter which way round this is, but considering the number of singers came first, it just seems logical to make them set A. So here's our Venn diagram. We're going to remember that set A has a total of 14 and set B has a total of 12 because we can use that to check things at the end. And ideally, we want to start in at the intersection where possible. So the intersection, remember, is people who fit both criteria at the same time, or whatever fits criteria at the same time. That's what we're putting in the middle, whether it's people or something else. In this scenario, we are told that there are 5 people who do both, 5 students who do both. So 5 is what we're going to put in our intersection. And the reason that is a good idea to start in the intersection is this next part. A lot of people make a common mistake. We know that set A has a total of 14 people. So what number are we going to put here? A lot of people would just put 14 again here, and that's not quite right because we want everything inside this set to add up to 14. So this number here must be 9, okay? We're including 5 people who can sin already because they can do both, but that number is 9. By the same logic, this number here is 7 because the entire set needs to add up to 12, but we've already got 5 people included because they can do both at the same time. Just add up these numbers. We call this your union, by the way, anywhere inside the circles. 9 add 5 add 7 is 21, but we were told 32 people were surveyed, so there must be 11 people who responded that they couldn't sing and they couldn't play a musical instrument. So there's our Venn diagram. Remember, we were asked for the number of students who sing, but emphasis on who only sing. So the people who only sing are 9. Okay, so there's 9 students who are just singers. Again, super impressive, but we just got to be careful because the criteria was sing only, not sing and plays an instrument. So your answer is 9. However, it's not always as obvious what the number in the middle is in your intersection. So let's have a look at this situation. A teacher training workshop, 110 participants were surveyed about their study habits, particularly 2 study habits. Whether they use practice questions, where 70 people responded that they did. Whether they watch explanatory videos like this one, which 55 people responded that they did. 10 people responded that they didn't use either method. They might be used something else, and that's fine. But there were 10 people who said that they don't use practice questions and they don't watch explanatory videos. They probably do something else. We want to find the probability that a participant uses both the study habits, practice questions, and watches videos. So here's our Venn diagram. Set A is our practice questions people. Set B is the people who watch explanatory videos. We're told that 10 do neither, so we can place that on the outside already, which is quite useful. But getting the intersection is tricky this time. But what we're going to do is we're going to look at a total. We have 70 people here, 55 people here, and 10 people here. So when we add them together, that gives you 135, which should strike you as a bit odd, considering that the question says there were only 110 people surveyed. What's happening here is that some people are being included twice over. They're being included if they watch practice questions, and then they're being included again if they watch explanatory videos. So 135 is 25 more than the number of participants in the survey, and that is telling us there are 25 people who fit both criteria. 25 is our intersection, and that is why we're getting a number bigger than 110, because they're currently being included twice, okay? So again, we've got our intersection, but a bit trickier to get that to start with. Now we've got our intersection low, we can rely on the same technique as last time. We know that entire set has to add up to 70. So this number here must be 45. So there's 45 people who use practice questions but don't watch videos. And then this number here must be 30 because this entire set must add up to 55. We've got 25 people who do both. So that must mean that there's 30 people who rely on videos and not practice questions as their study technique. We were asked for the probability that they use both study habits. So from the Venn diagram, we can now see that 25 people use both study habits. But as a probability, that is 25 over 110. Okay? As a probability, we want to put it as a fraction, unless we're asked otherwise. We can simplify that fraction down to 5 over 22. And you might be thinking, is a decimal fine? Yes, it is. If the question doesn't say, in all fairness, you should get it regardless. But probably the easiest way is to write it as a fraction first, because that's entirely accurate. And we don't have to do any further calculations to get a decimal answer or a percentage equivalent. So that was a quick introduction to Venn diagrams. There's lots of other things that we will look at in future videos, but in terms of your Landtite assessment and in terms of when you first see this concept in secondary school, this will be a good starting point and what you need currently. If you are going on to study it further, I would say in like year 10, then you are more than welcome to watch our other videos where we look at more concepts related to Venn diagrams. So if you want to support me, You can check out PeerPath Learning at peerpath.com.au. Also on Facebook and Instagram, there's always a bunch of resources there and tips and techniques that I share just to build a positive mindset around mathematics. And also in the description of this video, there'll be some free resources to help you out, as well as links to other things that I think you will find useful. I wish you all the best if you are taking an assessment soon, and I will speak to you again in another video. Bye now.